right, last examples for this lesson. I'm going to do a trapezoid again and then an obtuse triangle, which looks a little bit different than the triangles we've seen in the past. So the first one's the trapezoid, which we, in the last example, broke up into two triangles and a rectangle. Right, so I'm looking at this triangle. That was a terrible one, sorry. And then this triangle here. So if I want to find the area of both of those triangles, and then I will then find the area of this, in this case it's a rectangle, in the middle here. The rectangle is nice and easy. Maybe I'll do that one first. The area of the rectangle is length times width. Right? If you want to pause it and go ahead and find your length and your width and multiply them. Right? And then you should have gotten 3 times 6, which is 18. So I'm looking at this area being 18. Okay. Now I need to find the area of my two triangles. Now if I notice my base and my height, 3 is opposite 3, are the same. So my triangles are actually going to be the same area. I don't have to find them separately. Another way you could think about it is if I were to take this triangle here and I can kind of turn it and put it over here, it would actually make a rectangle. So it's just another way to look at it. But I know that the area of a triangle is base times height divided by 2. So both of them are the same in this case. Not always, but in this case, they both have the same base and the same height. So it'd be 2 times the height, which is 3, divided by 2. And then if I have 6 divided by 2, that would give me 3. So each of my triangles has an area of 3. Okay, so now that I have all 3 areas, go ahead and add them up. 3 plus 3 plus 18, which gives me 24. I think that was the same as the last example. Okay, so my area of that trapezoid would be 24. Okay, now we're going to move on to the area of an obtuse triangle. And if you want to pause and try it on your own and see if you get it right, I think that would be a really great way to challenge yourself. So go ahead and do that if you'd like. And then I'm going to go through and make sure that we do it so we know if we got it. So area of a triangle, it doesn't change. Still base times height divided by 2, even if it's an obtuse triangle. Okay, but now I'm looking at this triangle. I'm trying to think, what is my base and what is my height? Okay. Now you're probably looking at this and you're saying, well, what is my base? Because I see a couple numbers here at the bottom. I have an 8 and I have a 3. And in the last example, we added the two of them together to find the total base of my triangle. However, if this is my triangle right here, my base does not go out here to this section, okay? I want to make sure that I'm just doing my triangle. Now, the only reason it does go out this far is because that helps me out here, because that helps me to see where the height is. That's the only reason they go out there. So this is actually unneeded information. And my base is 8. This is going to be my base. My height, I need to make sure it's at that right angle. Okay, I can't do a slant. I'm not doing it that way, right? So my height is actually going to be 4, and that's the only reason it went out there. It could have been up here, right? That could have been the height there. It could have been 4. Okay. So I kind of drew on that a lot, so I'm going to erase a bunch of it. Base of the triangle is 8. Here's my base right there. My height is how tall it is from the base all the way up to the top of the shape. So my height is 4. So if I'm doing base times height divided by 2, which I already did, I don't know why I rewrote the formula. Okay, I'm rewriting it 8 times 4 divided by 2. Right, 8 times 4 is 32. Divided by 2 gives me 16. Okay, so the area of this triangle is 16. So this is extra information. Don't use that. If the actual base went that far out, then you could have added the 8 and the 3, but the base of the actual triangle is only 8. Okay. Go ahead and give the rest of them a try.